We can do a problem to find the gain margin and phase margin. So the question is, determine the gain crossover frequency, phase crossover frequency, gain margin and phase margin of a system with open loop transfer function g of s is equal to 1 by s into 1 plus 2s into 1 plus s. So first step is to find the phase crossover frequency and gain margin. For that, we are writing g of s is equal to 1 by s into 1 plus 2s into 1 plus s. Here we are substituting s is equal to j omega, so that we will get g of j omega will be equal to 1 by j omega into 1 plus 2j omega into 1 plus j omega. We can multiply the terms inside the bracket, so that we will get 1 by j omega into 1 plus j omega plus 2j omega minus 2 omega square. That will be equal to, again j omega can be multiplied to the inside quantity, so that we will get 1 divided by minus 3 omega square plus j omega into 1 minus 2 omega square. So this is the g of j omega equation. There will be real part and imaginary part. So next we want to find out the phase crossover frequency. So we have a condition that at phase crossover frequency, imaginary part of g of j omega will be equal to 0. So we can substitute when omega equal to omega pc, that is when omega equal to phase crossover frequency, the imaginary part can be equated to 0 to solve for omega pc. So this is the imaginary part. So here we can substitute omega equal to omega pc, so that we will get omega pc into 1 minus 2 omega pc square equal to 0. Here either this term will be equal to 0 or this term will be equal to 0, but we can clearly say that this will not be, this phase crossover frequency will not be 0. So the chance is 1 minus 2 omega pc square will be equal to 0. So we can solve for omega pc, so that we will get to omega pc will be equal to 0.707 radian per second. So next we can substitute this omega pc value into this equation of g of j omega. We know that at omega pc value, imaginary part will be equal to 0. There is only one chance is that there will be only real part. So we can find that gain margin kg, that means gain margin kg equal to 1 divided by modulus of g of j omega to omega equal to omega pc. So we know that at omega pc, imaginary part will be equal to 0. So there will be only real part. So that will be equal to 1 divided by modulus of 1 by minus 3 omega square at omega equal to omega pc. That will be equal to 3 omega pc square. That will be equal to 3 into 0.707 square. That is equal to 1.5. So gain margin in dB value equal to 20 log kg. That will be equal to 3.5 dB. So we have find out the phase crossover frequency and gain margin. Next we want to find out the gain crossover frequency and phase margin. For that again we are taking g of s, that is equal to 1 by s into 1 plus 2s into 1 plus s. Here we are substituting s is equal to j omega. So g of j omega equal to 1 by j omega into 1 plus 2j omega into 1 plus j omega. And here it is better to write it in the polar form to find out the magnitude and angle terms. So instead of j omega we can write it as its magnitude will be omega and phase will be 90 degree. So the first term is omega angle 90 degree, and next term is 1 plus 2j 2 omega. Here it is in the form of a plus jb. So its polar form will be square root a square plus b square. Also its angle will be tan inverse b by a. So here we can find the polar form as square root 1 plus 2 omega square, that is square root 1 plus 4 omega square, angle tan inverse 2 omega by 1, that is equal to tan inverse 2 omega. Similarly, we can write the polar form of this term, that is equal to square root 1 plus omega square, angle tan inverse omega by 1, that is square root 1 plus omega square, angle tan inverse omega. So in this case we can write magnitude will be equal to, what is the magnitude? 1 divided by, magnitude terms are omega, square root 1 plus 4 omega square and square root 1 plus omega square. So these magnitude terms will be multiplied. So we will get a modulus of g of j omega equal to 1 by omega into square root 1 plus 4 omega square into square root 1 plus omega square. And the angle can be obtained by taking the addition of these angles, that is 90 degree plus tan inverse 2 omega plus tan inverse omega. 1 divided by these angles are added, so that we will get, when we are taking it in the numerator side, we will get minus 90 degree minus tan inverse 2 omega minus tan inverse omega. So we got magnitude and phase terms. So next we want to find out the gain crossover frequency. We know that at gain crossover frequency, the magnitude of the g of j omega will be unity. That means gain crossover frequency is denoted as omega gc. At omega gc, modulus of g of j omega equal to 1. So we have the equation for modulus of g of j omega, which is 1 by omega into square root of 4, 1 plus 4 omega square into square root 1 plus omega square. Instead of omega, we can substitute omega gc. So we will have this equation, but you can see that it is very difficult to solve for omega gc by ordinary method. So we are making a trial and error method. So we are doing a trial and error method. That means we are simply substituting that omega equal to 1. So that what will be the value? We will check what will be the value obtained when we are substituting omega gc equal to 1. See, when omega gc equal to 1, we will get the value of modulus of g of j omega equal to 0.3. So it is far away from this one. So it is not the correct value. So next we are taking another value, that is omega gc equal to 0.5. So we are substituting in this equation, so that we will get a modulus of g of j omega equal to 1.26. That means it is somewhat nearer to 1. But again we have to make some take some different values of omega. That means we can find that from these two values we can conclude that the unity magnitude will occur for a frequency between 0.5 and 1. So we are taking a value 0.6. So when we are taking 0.6, the modulus of g of j omega will be equal to 0.915, that is by substituting for omega gc equal to 0.6. So it is lower than 1. So similarly, we will substitute another value of omega equal to 0.57. So that we will get a 1.005. That means it is somewhat more closer to 1 value. So we can equate omega gc equal to 0.57 by trial and error method. Okay. So let omega equal to 0.57, the gain crossover frequency. That means that is the gain crossover frequency. So that for that value of omega, g of j omega is approximately equal to 1. So gain crossover frequency omega gc is equal to 0.57 radian per second. And for that value of omega gc, we have to calculate the value of phase angle, that is phi gc. Phi gc will be equal to minus 90. We have the equation as, see, we have the equation for phi gc as minus 90 degree minus tan inverse 2 omega minus tan inverse omega. Here we are, instead of omega, we are substituting 0.57. So that we will get phi gc is equal to minus 168 degree. So we can find out the value of gamma, which is equal to 180 degree plus phi gc, that is equal to 180 degree minus 168, that is equal to 12 degree. So we will get all the values of phase crossover frequency, gain crossover frequency, gain margin and phase margin. Next we can do a homework, that is the open loop transfer function of the system is g of s is equal to k by s into 1 plus 0.1 s into 1 plus s. Determine the value of k so that the gain margin is 6 dB and determine the value of k so that the phase margin is 40 degree. So instead of k you can substitute this value. This is the 20 log k value, that is 20 log gain margin value, and you can make calculations and find the result, and the result is this one. For 6 dB gain margin, k equal to 5.5135, for phase margin 40 degree, k equal to 1.3787. Do it as a homework and check the result. Thank you.